All right, welcome to example 2 for quadratic maximum and minimum word problems. A company that makes crystal bowls has a daily production cost C in dollars given by the relation C equals 0.2 b squared minus 10b plus 650, where b is the number of bowls being produced. How many bowls should be made to minimize the cost? And what is the cost when this many bowls are made? So right here, I'm going to draw a parabola here to try to visualize what's going on here. So I can see that this has a value that is positive. And if the a value is positive, this thing is opening up. This is probably opens up. And the other thing I can extract from standard form is the last value here. The last value here tells us the y-intercept, or in this case, the c-intercept. So the c-intercept starts at 650. So let's draw this mathematically lens. So the only thing I know is that this is at 650, and this is a cost in dollars. And this is B, and this is number of bowls produced. Okay, and I know that this parabola is opening up, so it's going to go down, up, something like that. Okay, so we need to actually make sense of this situation. This is a company that creates crystal bowls. The cost to create those bowls is actually getting cheaper. So there's a happy middle part where the cost is minimized for a certain number of bowls. We know mathematically this is the vertex, so we have to find the vertex of this parabola here. So I'm going to write this parabola here, 0.2 b squared minus 10b plus 650. Now, this could, I don't know if this has x-intercepts or not. We could use the discriminant to figure this out, if you guys remember. This has been a while. So we use d, the discriminant, which is the inside part of the parabola, which is b squared minus 4ac. So b is right here, which is 10 squared, negative 10 squared, minus 4, which is a, 0.2, and c is 650, and this will be 100 minus 650 times 0.2 times 4, which is minus 520. So 100 minus 520 would be negative 420. So this will be the inside part of that quadratic, the square root of that quadratic. And if it's negative, which it is in this case, we know that there's going to be no x-intercepts. So we can't use the quadratic formula here to figure this out. We can't factor because there is no x-intercepts, or in this case, b-intercepts. So in order to do this, we'd have to complete the square. Okay, so in order to find that vertex, so convert from standard form to vertex form. Minus 10b plus 650. So we're going to factor out that 0.2. 0.2 only from the first two terms, so that's going to be, we have to divide, so 10 divided by 0.2, so that's 50b plus 650, and here we need to make this a perfect square trinomial. So in order to make it a perfect square trinomial, we're taking that middle term, that term right there, we're going to divide by 2 and square it. 50 divided by 2 is 25. When you square that, that becomes 625. So now this is the value that we have to add and subtract. 0.2 b squared minus 50b plus 625 minus 625, and that's from this value right here. And we have this plus 650 on the outside there. Now this is not quite a perfect square trinomial. We need to get rid of that last term here. So in order to get rid of that last term, we are going to distribute this 0.2 only to this last term. So now that we have a trinomial inside, so 625 times 0.2, 625 times 0.2 is going to be 125. It's going to be negative because we're doing 0.2 times a negative number, so minus 125 plus 650. And now we have a perfect square trinomial. We need to find two numbers that multiply to 625 and add to 50, and it's always this number right here, we found two numbers that multiply to 625 and are also half of 50, which is right there. So this value is going to be minus 25, and we got that from this part right here. I'm going to keep that same color. So two 25s, and then 650 minus 125, it's going to be 525. And so now we found our vertex. The cost is 525. That's my vertex there. With the B value, or the number of bowls being produced, is 25. So these, in order to minimize this production cost, we have to produce 25 bowls, and it'll cost $525. And that's the answer to this question. Therefore, 25 bowls should be made to have a minimum production cost of $525. Okay, if you guys have any questions, please email me or see me on Google Chat. Good luck.